Hello, my friends of Hatari Labs. My name is Saul Montoya. Please welcome to this webinar. This webinar is how to reproject, clip, and interactive plot HDFs. So HDF is a format of is a format of uh, it's a format like TIFF or like NextCDF for satellite imagery. Okay, so in order to do that, we will need to that you have. Okay, so please go to your store. Okay, okay. There were some instructions here. So the instructions were that are already here in the Hatari Labs. Okay. So in the mhm. uh, we need to see if we have the Windows subsystem for Linux installed. Unfortunately, for the people that do not have that installed, so here in PowerShell, okay, there are more people arriving here. Okay, great. So here in PowerShell, so we need to have a VWCL status, and it has to appear that we have the version number 2. Okay, so if you are here, okay, Ali is working in Mac. Wow, that could be an issue. Yeah, well, uh, I don't know. I don't know, Ali, how can you face this? Because, I mean, it's mostly because of the installation of the GDAL, okay? So, whether you... Mhm. Right. So, if you have... Okay, even Ali, if you are following us, please type 2. Okay, if you have if the version is number 2, please type 2. Okay, if you have Windows subsystem for Linux installed, please type 2. Okay, please type 2, please. Okay, great. Jamila, Lester, no. Windows 10. Yeah, but no, it's not the. You have to open. Okay, we have a problem here. Okay, you have to open PowerShell, and then here we have to WCL status WCL. Great. Jamila? Okay, if you have Windows Subsystem for Linux installed, please type 2. Okay, if you don't have the Windows Subsystem for Linux, you can install it with WES installed, but in my case, I have already installed it. CLS with Windows Subsystem for Linux installed, but I have already installed it, so that is why. Okay, um, so that is why here I just type status. Okay, great, great. Okay, yeah. Okay, okay. Jamila, I think that because the rate that we use this is much faster, so I will strongly that you follow the webinar, okay? And then you can do this at your own pace. Okay, so once you have installed that, let's work with let's do Jupyter notebook. And no, let's go to store, and on store you are going to install Ubuntu. Okay, there are several versions of Ubuntu. Yeah, I have the one that we are going to use here is Ubuntu. Okay, so we are going to use the 22.4.2. Okay, so this is the one that I am going to open that. Okay, so and why do we use Ubuntu? We use Ubuntu for a certain library that we are going to require. Okay, maybe for your case, okay, maybe for your case, you are okay. The user will be Hatari, yeah, and the password will be labs. Yeah, the user is Hatari and the password is labs. Okay, labs. Okay, yes. Okay. Once you are here in Ubuntu, in order to in order to have all the libraries working, okay, so we have to install some packages that are sudo apt install GDAL bin. Okay, labs is the password. Okay, so this is the, and then we have to install pip install GDAL. Okay, and then this will install the Python package of GDAL. Okay, that I have already done. So we are pip install IP widgets. Because why IP widgets? Because it comes with default. It comes as a default with okay. It comes as a default with um, it comes as a default in Anaconda, but it doesn't come here in Ubuntu. So that's why we have to install it. Okay, it's already installed. Okay, and then we have to install pip install geopandas. Okay, and as well pip install Jupyter Lab, Jupyter, Jupyter Lab. Okay, so this is, and then I have already installed it. Okay, great. If you are following me, please type 3. If you are following me, please type 3. Okay, please type 3. If you are following me, please type 3. I mean, if you are following the video as well, type 3. Doesn't matter if you actually are, it doesn't matter if you actually do the, hello? Okay, great. Okay, clear. Okay, great. So what we are going to do is that we are going to change so to the our document folder. So in when you are working with Windows Subsystem for Linux, you use mntc users, then you use this is my username. So for your case, it will be different. Okay, so this is my username. This is my username. So you will it will be your own. So we go to documents, okay, and in documents is where you have to place the data that you have downloaded. So here, so this is how to reproject. Wait, but for your case, the folder will be the folder will be Control C, will be this one. Okay, great. So it will be webinar of how to reproject. So webinar of how to reproject. Okay, great. So now we are from Windows Subsystem for Linux, but now we are here in the in our okay. So now we are with Windows Subsystem for Linux, but with on the documents. Okay, if you follow this, please type 3, 4, 4, 4. If you follow this, please type 4. Okay, great. So now we just run Jupyter Lab. Okay, Jupyter Lab. So we run Jupyter Lab, and it will prompt Jupyter Lab in our favorite browser. Okay, so let's see and let's wait. Okay, that if no actually doesn't come in your browser, you can copy and paste this. Okay, great. Okay, great. So I use the Jupyter Lab. I use the in the settings. I use the dark. Okay, so actually use well. Actually, you are going to see something like this, and then here we use the Jupyter Dark. Okay, we use the Jupyter Dark. Okay, great. Great, Amal. So we go to scripts, yeah, and then we are going to load the data. Okay, so we are going to create a new folder that is called part 1 because there are two parts. The first part that actually downloads the data, and the second part that actually uh, the first part actually downloads the data, and the second part actually do the clip and reprojection. Yeah. So first we need to install a package that is called pip install air access. Okay, so with that we install the library that is air access that I have already installed. Okay, and here we are going to import air access. Okay, so out is equal to air access dot login. So okay, great. So it will look for my username. Okay, so where is this? So if you go to, and it was on the description of the webinar, you have to create, if you don't have an account, you have to create that. Okay, I will drop this URL through the chat. Okay, you create your account. Okay, and then I have an account here, and this is from the NASA, so this is so, and this is my password. Okay, and I have already a credential. Okay, that will bring you a credential. Okay, great. Amal, if you are here with me, please type 5. Okay. Okay, for anyone that is here with me, please type 5. Okay, great. So we can see, we can look for results. Okay, we are going to use the, so this is air access dot search data. Okay, so we open that, and this is the short name, and the short name for the, we are going to work with a potential evapotranspiration. Okay, short name is equal to MID 16A2. Okay, so this is a nickname, and then you have to look for this name in the LPDAC. So you LPDAC. Okay, here is where they have a lot of process image, and from this process image you have to on data catalog. Okay, so you have a lot of process image where you can play around with. Okay, so this is cloud hosted is equal to true. Bounding box is equal to, let's give okay, temporal, that will be from 2021 0101 to 2021 1231. Okay, and then we are going to look, okay, so you have to drop a comma after each argument. Okay, so, and this is count, we are going to have 10. Okay, great. So here we have with 10. Okay, so okay, so what is here that for the evapotranspiration, okay, for this image, okay, we have for this dimension, this is in WGS 84, okay, and for these dates we have 46 granules, okay, but actually we are only going to take 10, okay, that is what it has, okay. If you are here with me, please type 6. If you are following me, please type 6, okay. Remember that the I will drop the I will drop the link afterwards, so actually you can follow this. Okay, great. So then we see data links is equal. Okay, so we want to download this data. Okay, so this is really easy. So files is equal to r access, okay, dot download. Okay, we are going to the results. We are going to store in MID images. Okay, so and with that it starts it's results. Okay, with that it starts. Okay, so it says that some of them are already downloaded, and it's already is downloading the ones that are not downloaded. Okay, so 6 of them are already here. Okay, and 1 2 3 4, yeah, the 10 of them are already there. Okay, well, it says that it's still working. Okay, so let's see what it has, what it will bring us. So let's open the part 2. Let's create another that is the part 2. Great. No, not here. Let's delete. Not here. Okay, in scripts, let's create the part 2. Okay, great. Okay, so now we are going to work with from osgeo import GDAL, import your pandas as GPT, import matplotlib.pyplot as PLT, import OS, import numpy as np. Okay, great. So, okay, we need GDAL. Okay, why we need GDAL? Because we are working with HDF, and HDF is a format that is not easy to handle with any other. Okay, there are some libraries, for example, Pandas can open HDF. Okay, and as well, which other one that can open HDF is uh, Pandas, and there is another one that is mm, PyHDF, but they work with HDF5, and this is HDF4. So that is why. So, okay, so we are going to list the HDF files. Okay, HDF files list is equal to file for file in os.listDir. Okay, MID image. Okay, so here we are going to work with MID. Okay, for all the files that are here, if the first last characters, okay, are equal to HDF. Why? Because you can have also another temporary files or something like that. Okay, so with that HDF list, the first 5 lines are these ones. Okay, great. Yeah, Rasterio cannot do Rasterio can open HDFs. Okay, Rasterio can. It actually can. Okay, so we are going to open one HDF file. So let's open one HDF file. HDF file is equal to gdal.open post path join. Okay, MID images HDF list 0. Okay. Okay, with that we have opened the first HDF. Okay, we have opened the HDF, and let's see which are the subdata sets. Subdata sets is equal to HDF file get subdata sets subdata sets. Okay, these are the subdata sets. The subdata sets. Okay, and it comes in 5. Okay, HDF means hierarchical data format, and it comes with actual evapotranspiration, potential evapotranspiration, and some QAQC, latent evapotranspiration, or something like that. Okay, so what we are interested in the first array. Okay, so what we are interested is in the first array. So that is why here so that is why here that is sorry. Uh, sorry. That is why here we have let me arrange my okay. That is why here we have to open the first dataset. So etban is equal to gdal.open of subdatasets of the first offer. Okay, this is how you open the datasets. Okay, and this actually works here. Okay, because in the okay, because I have another kernel that has Ubuntu, yeah, and it doesn't work in that way. Okay, so what does it mean? Okay, let's see that it works in this configuration. So maybe if you work in another configuration, you are going to have some problems. Data array. Okay, and then here we can plot the band. Okay, so this is the visualization of the evapotranspiration band because there are a lot of another evapotranspiration. Okay, if you are here with me, please type 7. If you are following me, please type 7. Okay, so we can srt srs is equal to et band dot get spatial ref. Okay, src srs dot export to pro4. Okay, so this is the sinusoidal projection. Okay, so and this is not WGS84, so this is another type of projection. So we have to, okay, what we are going to do is that we are going to clip this. Okay, we are going to clip this. Okay, and then we are going to reproject that, and then we are going to plot that as well. Okay, so because this projection is actually kind of arbitrary, okay, so we cannot work with that. Okay, great. So we have here, okay, in order to clip it, we have here a shapefile. So here we see SRS. No, we are going to open AOI is equal to GPD. We use GeoPandas. GPD.read file. Okay. Okay, from the shapefile, and it will be AOI.shapefile. Okay. So, and then here we see AOI bounds is equal to AOI log 0 because there is only one polygon here. Okay, there is only one polygon here. So we look for the geometry and then we look for the bounds. Okay, so list of AOI bounds. Wait. Uh, iLock. This is iLock. Okay, so this is the bounds of the area of interest. Okay, so where we are, this is an WGS84. Okay, this is where we want to clip this the layer of evapotranspiration. Okay, if you are following me, please type A. So GDAL file. Okay, so we are going to translate this. Okay, first we are going to translate that because it's in this sinusoidal projection. So we are going to translate it to WGS84. So HDF file is equal to GDAL.open ospat.join. Okay, mad image. Okay, of the first HDF list 0. We have to close with two parentheses. Okay, subdatasets is equal to HDF file dot get subdatasets. Okay, so et band is equal to GDAL dot open subdatasets. Mhm. Okay, so we open that. Okay, and then we define the translated data set. Okay, so this will be trans data set is equal to os.bind.join, and this is in another folder that this is mid tif. Okay, and this will be, the name will be HDF. So we are working with the first HDF. So this is the first HDF, and then we have to change of extension. So that is will be .tif. Okay, great. So, and then we are going to, the arguments we are going to insert as a dictionary, and this is really fancy because we we just, okay, so we create a dictionary where the system of reference of the destiny system of reference will be equal to EPSG of 4326. Mhm. Okay, and warp is equal to GDAL dot var. Okay, so we are going to use the GDAL dot var. Okay, of the where the destiny will be trans ts. Okay, and the source will be the band, not the file, but the band, only the band. Okay, meaning the array. Okay, well, not the array, but just the band. Okay, and then we insert the arguments, the dictionary as arguments with the double, with this double asterisk. Okay, trans args. Okay, and then we close this var equal none. Okay, great. Okay, I have an error. GDAL, GDAL, what is GDAL? It's trans ds with capital D. Okay, so if we go here to MID image, so you are going to find, okay, so let's see, let's do that again. Delete, delete. Okay, so if I just, okay, I will run my whole kernel. Oh, oh, really sorry. Okay, let me see if Control Z actually works. I I made a mistake. I have, okay, wrong also. Okay, I have deleted the files, not the clipped file, but okay, I wanted to, okay, okay, I wanted to delete these files. Okay, sorry, I wanted to delete this file. Okay, now it's downloading. Okay, again. Okay, great. So I can work with this. Okay. Mm-hmm. Mm, okay, okay. Uh, what I will do is, since I have the webinar, okay, I have here in META image. Okay, I'm going to copy paste this, okay, because it's taking so long. Or mm, okay, it seems that okay, or maybe mm, okay, mm, what I can do. Okay, I will do. Okay, still downloading all the files. Okay, so and there are just 10 of them. Here I have 8. Okay, let's wait a little bit. There are 270 megabytes. Mhm. Okay. I will do a pause in the video, but let's wait. Okay, now it's working. Okay, so it seems that it has finished downloading this file. Okay, and it will look for the other. Okay, so I just redoing all my stuff. Okay, I have a GDAL. This is GDAL, and this is TransDS. Okay, great. So what does it mean here? In my id.tif, I have this is a TIFF file already, and this is a TIFF file of the that is already reprojected. Okay, so what we are going to do next is that we are going to clip it. Okay, so how we clip it? Okay, so we are going to clip no arcs is equal to cat line. Okay, so we are going to use the ds name as, and this is the argument. Okay, okay, so this is where we are going to use. Okay, so we are going to use this shapefile AOI. There is a question, please. Which is the question? Yeah, open the mic and drop your question, please. So once we have clipped, we can crop to cut line. True. Okay, and when we find no data, so dst no data is equal to 0. Okay, and here is trans file is equal to GDAL open Okay, so the translated file, we are going to store it in IMAD clip. So translated data frame, data set is equal to ospat, okay, join MID clip HDF list of 0 of to the minus 4 plus dot tiff. Okay, so the translated, the clipped will be also tiff. Clip tile is equal to GDAL dot warp clip ds transfile with the trans r trans, and then we close that because otherwise we cannot open the open. If we keep it open, we cannot do the process again. No? Okay. And with that, okay, so the first part, actually what it does is that clips the file, okay, that clips the file, okay, no, that reprojects the file, and the second part that also clips the file. Could you do this in one sentence? Maybe you can do this, but I'm actually I wasn't able to do it, and I wouldn't spend much time. Okay, so this worked for me, so that is why I have done it in this way. Okay, if you are here with me, if you are following me, please type 9. If you have any questions, let me know. Okay, so this is the, okay, so this part actually change of format. Okay, and this part clip it to the part. Okay, so if we run this in the folder MID clip, we see the TIFF file, and this TIFF file is already a um, is a is a TIFF file for the evapotranspiration band on the extension of the area of reference. Okay, great, 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 great. So we can plot. Okay, so we can plot. So we can plot. So clip file is equal to GDAL. Uh, well, we can plot the GDAL dot open MID clip, this one. So clip band is equal to clip file dot get raster band. Okay, so because the T file only has one band, read as array. Okay, plt image show clip band norm is equal to simlog. Okay, read, this is point. Okay, so this will plot the clipped file. Okay, so this was the whole file. Uh, this was the whole file. And this is the reprojected one. And it has to be on the extension of the, this is already in WGS 84. Mhm. Yeah, because the as we have seen, well, as we have seen here, no, but this has to, no, it has to clip this MIT clip. Wait, wait, wait. Wait, 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 wait. Wait, wait, wait. No, because as you see here, this is not this is the whole mm, this is the whole HDF reprojected. So, but this is only 13 megabytes, while in image this is 26. So it has to be smaller. No, MIT TIFF. No, no, it's the same. So that what does it mean? That is actually not cutting. So let me check this. No, what it says here is that it's actually not, I mean, it's not clipping. But why is not clipping? Ah, okay, okay, okay. Because here this is clip arcs. Okay, these are the clip arcs. Okay, so when now is clipping. Crop to clip now arcs. Crop to cut line. Crop to cut line. Says that this doesn't work. Okay, so let's see. Okay, let's see. Now, no, it's still okay. If I plot this, so what it will prompt is this with just the value here. That is why I have to use this clock to. So this has to work. Okay, let me check. Let me check. Crop to cut line, comma. Ah, okay, okay. So this is not varp. Ah, cut line ds name. Sorry. Okay, let me check. Okay, you can always check the error. Uh, mm, 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 mm. Well, what it says is that this crop to cut line is not working. Clip now arcs. Okay, shape. Crop to cut line is equal to true. Okay, trans file GDAL open trans ds clip ds ospat my clip HDF file clip type verb. Mm, yeah, because what you are seeing is that it's just structuring. Okay, so this is okay. So if I put minus my man, okay, let me check if this works. Okay. Mm, mm. Let me wait. Come. Yep, yep, yep. Yeah, this should work. This should work. Crop to cut line. Zero. Okay, let me copy and paste this. Yeah, okay, yeah, and that work. Why this work? Okay, yeah, that work, but why? Why cut the line this? I don't know why, but if I paste this, actually works this way. okay, actually works, and this is how. Okay, so you have done just, I mean, you have clipped for just one, you just have clipped for just one plot. Okay, so we are going to clip it for the whole set. So here we copy and paste this. Okay, so we are going to do for HDF file in HDF list. Okay, so we paste this. Okay, and this will be HDF file. HDF file. So this will be HDF file, and this will be HDF file, and that's it. Yep. So we run it. For HDF file, and this is HDF DS, because this is HDS DS. Okay, let's see if that works. Yep, it's working. Also, it's doing the translation and clipping. Mhm. It's doing the translation and clipping. Okay, great. So now we have MIDDS. Okay, so we need some threshold for the visualization. GDAL open. So open os.path.join. So mid clip HDF list of 0 plus mid band midds get raster. I need these values because otherwise the color bar in all the visualizations will have any scale. So I have to give some maximum and minimum. Read as array max value mp quantile of mid band, and then I get the quantile 0.99. Okay, so the max value that it will be on my color bar will be MIETS 264. Okay, great. So, okay, so with that, we get a function that will plot it will plot a file. Okay, so this is def plot mid, but instead of a file will be an index. So HDF index, HDF name is equal to HDF list of HDF index midds is equal to either dot open os dot path join MID clip HDF name plus diff. Okay, MID band is equal to MID DS get raster band of 1 and read as array. So we give a title that the year is equal to string and the day. Mhm. Mhm. The minimum value is 0. Yeah, and the plt dot color bar So if we plot the MID of the first index, that will be okay. I have a problem. Ospat join plot MID. Okay, MID. So HDF list, HDF list. Okay, HDF list of of 0. MID clip. Okay, so say print. What is going on here? HDF name. So this is MID clip. MID 210. IP9 069 221 06242.tif. Entonces, they tell me that MID da, 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 001. That doesn't, they tell me that this doesn't exist. MID clip, MID clip, MID name plus div. Why does it exist? Okay, I will run everything again and run all cells. But I see that here. So MID clip. MID clip, MID 2107.div. Don't know. Wow. It's so strange because if you see it's here, the file is here. Let's see if I can do it with one MID clip there. But it's here. I don't know. I mean, let me copy and paste this MID. I don't know. I mean, this is from the, yes, something is going on here. I don't know. I mean, maybe it's a character or something. Okay, but this is coming from the, well, don't know what is going on. Don't know. Well, yep. So, and then here we are going to do from IP widgets import interact. Okay, import IP widgets slider is equal to IP widgets dot in slider. Okay, the arguments will be value is equal to 0, min is equal to 0, max is equal to length of the HDF list minus 1, step is equal to 1, description is equal to HDF index, disable is equal to false, continuous update is equal to false, continuous continuous news is equal to false, orientation is equal to horizontal, read out is equal to true, read out format is equal to D. So if we interact plot MID HDF index equals to slider, we could see the different visualizations on the potential in the actual evapotranspiration on the site for the different days. Okay, as an interactive slider. Okay, great, great. So that will be the end of this webinar. Do you have any questions? Okay, do you have any questions? Okay, so I will stop the